Hello friends, welcome to my channel. Let's have a look at today's daily challenge problem. Problem 2225. Find players with 0 or 1 losses. So in this video, we're going to give a treatment based on graph algorithms or graph concept. So the so-called indegree and outdegree. So first, I'll read through the problem statement to digest the requirement. And then we do the analysis, and finally we share the code. First, the statement. We are given an integer array called matches, where each matches contains a winner and a loser, which indicates that the player winner defeated player loser in a match. So we are required to return a list called answer of size 2, where answer 0, which is a list, it contains all players that haven't lost any matches. The second element, or answer 1, is another list which contains all players that have lost exactly 1 match. So the values in the two lists should be returned in increasing order. So here means that we need to do a sorting. So notice that we should only consider the players that have played at least 1 match. The test cases will be generated such that no two matches will have the same outcome. So the first one is relevant to us. The reason is that so the player should have played at least 1 game, right? So here are 2 examples. So example 1, we're going to use it to analyze the algorithm. So in example 2, so you can have the output. So according to the explanation here, so the constraints for the problem are the following. First, the matches as a list, the length is bounded above by 10 to the power 5, and also it's not empty, right? So each of the match is a list 2 list contains a winner and a loser, right? So winner does not equal to loser, and all matches are unique. So with that said, so we are ready to do the analysis. So here we're going to treat this problem as a graph problem. So we're going to practice some basic concept in graph theory, the so-called indegree and outdegree. So here, so if matches I equals winner I, loser I, it means that there. So here, let me change this one. There is a directed edge from winner I to loser I. So in other words, so there is an indegree for loser I, and there's an outdegree for winner I, right? So we just need to do a linear traversal of the matches, and then record the indegree and outdegree, and then we do the return according to the problem requirement. So that's our scenario for this problem. So then the logic for this problem, first we want to find all players that have not lost any matches. So this actually corresponds to players with outdegree greater than 0. It means it played, right? So at the indegree equals 0. So together, it means for this the player, the degree sum of indegree and outdegree is greater than 0. It means it played, he or she played, and so they have no indegree, so no loss. So this is one. So the all players that have lost exactly 1 match, so equals players with indegree equals 1, because the indegree is already 1, right? So for sure the sum of indegree and outdegree for this player is greater than 0. It means it played, he or she played. So with this idea, so we can walk through example 1. So for example 1, you can examine the indegree is given by this dictionary. So here the K is a player ID, and the value is the degree. So in other words, the indegree means the matches this player lost. So the outdegree, so for example here K is a player, and the outdegree, the value is number, which counts how many wins for this player. So here in this problem, the players that played and without loss, it corresponds to this list comprehension, right? So for those players K, such that the out degree is greater than 1 and the in degree equals 0. And the players that have not lost exactly one match is correspond to the players with in degree 1. So in this example, so the first one is 1 to 10. The second one is 4, 5, 7, 8. So these two lists are actually after sort, right? So if you do list comprehension, because we are iterating over a dictionary, so this order is not fixed. So like this, right? So we need to do a sort. So actually for this problem, so the main time is consumed in the sort, because sort is an n log n algorithm. So n is the sorting object length, right? So when we do the iteration of this matches to get the in degree and out degree, so it's just linear time, right? So actually, so if you need to draw some picture, it's also a good thing to do. You can draw a picture to digest the in degree and out degree. So before we write code, here is an extension. So in topological sort, for example, the cost scheduling type problem in Leetcode, so a natural way is to use Kahn's algorithm. So you can see this Wikipedia page. So in this algorithm, actually the concept in degree is actually an important ingredient. So the corresponding relevant video in the playlist is for Leetcode 207. So it's listed here. You can have a look or watch in the playlist or in my channel. So with that said, we are ready to write this code. So writing the code actually is rather straightforward. So here, let me do this. So in degree, so I'm just going to be a collections default dict. So I'm going to use integer, right? So you can do twice. So let me write another line. So out degree. So it's again the same. So I'm going to use a default dictionary as a subclass of dictionary, and then the value is integer. So with that stage, so we can first iterate over the matches. So for winner and the loser in matches. So we're going to do the in degree. It means lost, right? So the loser is incremented by 1, and the out degree, so of the winner, so incremented by 1. So once you have an in degree, it means you lose one game. If you have a out degree, it means you or the player won the game. So with that done, so actually you can print out this in degree and out degree. So but now let's not do it here. So here, no loss. It means that, so let's use the list comprehension for key v in out degree items if v is greater than 0, and the in degree of this key so is 0, right? So there's no loss, but we need to make sure that we only consider the players that have played at least one match, right? So this greater than 0, actually it means greater than or equal to 1, right? So another one is one loss, exactly one loss. So for this is very simple. So for key v in degree, we can directly check in degree items. So if v equals 1, right? So it must have the player must have played, because of this in degree is greater than 0. So now we need to do a sort to conform to the output format. So loss sort. So here we are doing sorting in in-place fashion. So then we're going to return so no loss, var loss, right? So with that finished, let's do a check. Yeah, it passes the first example. As we mentioned, you can print out this in degree and out degree. So for example, so in degree, so which is in degree, similarly out degree. So let's call it out degree. You can check for the first example, right? So this is the indegree and this outdegree, and you can copy and compare with here, right? So with that said, so let me do a check for the generic case. Let me comment out this part. So now let's check again. So yeah, it passed the first example. Now let's look at the generic case. Yeah, it passes all the cases. Let's test again. Yeah, so slow. So yeah, with that said, I guess that's about it. As I mentioned, so you can check out Leetcode 207 to practice the use of indegree. So you can also check out other relevant problem in the graph problem playlist in my channel. So with that said, I guess that's it for this video. Thank you.